You are welcome to another section of Global Kids Academy e-learning. My name is Akiyemi Sametosin, your mathematics teacher. Last time, we discussed quadratic equation, where the definition of quadratic equation was stated, some examples of quadratic equations, method of solving quadratic equations, and the use of quadratic formula to solve some quadratic problems. Today, we will continue by considering another method called the completing the square method. At the end of this lesson, you are expected to know how to derive the quadratic formula and solve some quadratic problems using completing the square method. Completing the square method. By the name completing the square method, it means that a term is added to the expression on the left-hand side to make it a square. Steps required to solve a quadratic equation of the form ax squared plus bx plus c equals to 0 by using completing the square method as follows. Here, the steps to solve any given quadratic equation of this form are stated below, and we will be using each of the steps to solve this general form. The first step says, move the constant term to the right hand side. So it means that this constant term will be moved to the right hand side. Then you have ax squared plus bx is equals to minus c. The second step says, divide both sides by the coefficient of x squared. That is, you have to divide both sides of this equation now by the coefficient of x squared. The coefficient of x squared here is a. So you have that is this a, you cancel this a, and so you are left with this equation. Now, as I explained earlier, that a term will be added to the expression on the left hand side to make it a square. So now, the third step is now saying that we should complete the square on the right hand side by adding this term to both sides. So you have, now that we are done with the first step, let's move to step 2. Step 2 says, divide through by the coefficient of x squared. The coefficient of x squared here is a. So it means that I will divide the first term here, which is ax squared, by a. Then divide the second term by a, and the constant term on the right hand side by a. So this a will cancel this a. Then I'm left with x squared plus bx over a equals to minus c over a. Through with step 2, we complete the square on the left hand side by adding b over 2a all squared to both sides. So you have x squared plus b over ax plus b over 2a minus c over a plus b over 2a all squared. Now you notice that this term, a constant b over 2a all squared, has been added to the expression on the left hand side and also the term on the right hand side. So simplifying the terms on your right hand side, you have this as minus c over a plus b squared all over 4a squared. And when you simplify the expression on the right hand side by LCM, you have 4a squared. A in 4a squared will give you 4a. 4a with times minus c, then you have minus 4ac. Then plus 4a, we divide 4a squared to have 1. 1 times b squared will give you b squared. Now, the term on the right hand side can be written as b over 2a all squared equals to b squared minus 4ac all over 4a squared. Now, you notice that the expression on the left hand side can be written in form of a squared, and that is what the next step is saying. The next step says that rewrite the expression on the left hand side as a square and evaluate the unknown variable. So let's write this first as a square before evaluating the unknown variable. So we have it as x squared x plus b over 2a all squared, which is equal to b squared minus 4ac all over 4a squared. Now, when you expand the expression on the left hand side, you get back this. So now we've achieved the aim of using the major aim of complete the square method, which is to make the term on the left hand side a square. Now, to evaluate the unknown, it means that we want to get the value or an expression for x. So to do that, you square root both sides to have x plus b over 2a all squared is equals to plus or minus square root of b squared minus 4ac all over 4a squared. Now, the reason why you have to add plus or minus is because when you take the square root of a perfect square, the answers will be both in terms of positive and negative. Take for instance, you are looking, the square root of 9 will give you plus or minus 3. That is, you have plus 3 or minus 3. Now, when you square your answer, you are expected to get the 9. You are expected to get 9. So when you square this, you are going to have 3 plus squared, which is plus 3 times plus 3, which is 9, positive 9. Then we have minus 3 squared, which is minus 3 times minus 3. Minus times minus will give you plus, then 3 times 3 will give you 9, which is exactly the same value we have inside the square root. So anytime you are asked to find the square root of a number, always remember to add plus or minus. So now, the square root will cancel this squared. Then you have x plus b over 2a. Then, in sort, you should remember that square root of m over n is also written as square root of m over square root of n. So that means that this term you have on your right hand side can be split into these two forms as this minus 4ac all over square root of 4a squared. Now, square root of 4a squared is also the same thing by writing square root of 4, which is 4 times square root of a squared, which is 2 times a, and the answer is 2a. So it means that this will now be square root of b squared minus 4ac all over 2a. Now, making x out of formula, you have x to be minus b over 2a plus or minus square root of b squared minus 4ac all over 2a. So these are like fractions because the denominators are the same. You have 2a, you have 2a. So what we just do is to just add or subtract denominators. So you have this as b squared minus 4ac all over 2a. We've applied complete square method to solve this general form of the quadratic equation to get the unknown x, and it's given as x is equals to minus b plus or minus square root of b squared minus 4ac all over 2a. Now when you look at this formula here, you discover that it is exactly the same with the quadratic formula that was discussed in the last class. So in a nutshell, we've been able to derive the quadratic formula using the completely square method. Now, we'll solve some examples of quadratic equation with constant coefficient, meaning with coefficient having real numbers as their values. By completely square method. The first one, you have 2x squared plus 12x plus 18 equal to 0. The second example, you have x squared minus 5x plus 6 equal to 0. The third one, x squared minus 9 equals to 0. We'll be solving these examples using these 4 steps of completely square method. Solution. The first one, we have 2x squared plus 12x plus 18 equals to 0. Now when you compare the given problem with the general form of the quadratic formula, you discover that your a is 2, b is 12, and c is 18. So the first thing to do is, by the method now, using the steps, move the constant term to the right hand side. The constant term here is the term without the variable x, which is 18. So you have 2x squared plus 12x equals to minus 18. The second step says, divide through by the coefficient of x squared. For this given problem, the coefficient of x squared is 2. Our a here is 2. So you divide all through by 2. And so you are left with x squared plus 6x, 2 here 1, 2 is 12, 6, is equals to 2 here 1, here 9, is equal to minus 9. The third step says to complete the square on the left hand side, you have b over 2a squared. b over 2a squared over 2a all squared means b is 12, a is 2 all squared. That is, you have 12 over 4 all squared, which is 3 squared. So you have x squared minus 9 plus 3 squared. So you have x squared now plus 6x plus 3 all squared. Then this is minus 9 plus 9. When you simplify the term on the right hand side, you have 0 here. Then this is x squared plus 6x. And when you express this expression here in terms of a square, that is what the first step is saying. You are going to have it as x plus 3 all squared. X plus 3 all squared. So how did I get that? Let me explain. Now, considering that you have two terms that are squared here, the first one is x squared, and the second one, and the last term here on the left hand side is 3 squared. So you have this x will come here, then the 3 will also, together with the sign inside the bracket. So you have it as this. So x will be here, then this 3 will also come here. Then you have squared here. So now, evaluate this to get the value of x. The first thing to do is to square both sides. Square root both sides. Square root both sides to get x plus 3 all squared. When you square root this, and remember to put your plus or minus, and when you square root 0, fortunately 0 is neutral, so you have 0 to be the answer there. But let me just put plus or minus. So this square cancels this, so you have x plus 3. What that means that you have x now to be equal to minus 3 plus or minus 0. So it means x is equal to minus 3 plus 0, or x is equal to minus 3 minus 0. And that will give you x equals to minus 3, or x equals to minus 3. So x is equals to minus 3 twice. Ax squared plus bx plus c equals to 0. You discover that a is 1, b is equals to minus 5, and c is equals to 6. Now, the first step says move the constant term to the right hand side. So you have x squared minus 5x to be equal to minus 6. The second step says that divide through by the coefficient of x squared. Now, for this example here, the coefficient of x squared is 1. Dividing both sides by 1 or divide through by 1 means that it will retain the term the way they are, because anything divided by 1 is that same thing. So it means that we'll skip step 2 and move to step 3. Now, we are to add a constant term, a constant to both sides of the equation. So you have b over 2a. b over 2a squared will give minus 5 all over 2 times 1 all squared, which is now written as minus 5 over 2 all squared. So we are to add minus 5 over 2 all squared to both sides of this equation. So it means you have x squared minus 5x plus minus 5 over 2 all squared equals to minus 6 plus minus 5 over 2 all squared. Now, from our previous explanation, I said that after you've added the term, you've made the expression on the left hand side is squared. You express you rewrite the expression on your left hand side as a squared, that is, it should be raised to power 2. And to do this, you bring this x from here as this, then the term in this bracket, you write it together with the sign. Now this particular example, the sign this term here is minus 5 over 2, so you have minus 5 over 2 in this bracket. When you expand this, you get back this expression. So you simplify the other term on the right hand side, then this square will affect the numerator and the denominator, and minus 5 squared all squared will give you 25, then 2 squared will give 4. Then you further simplify this using SCM. So you have 4 here. 1 in 4, that is 4 times minus 6, you have minus 24. 4 into 4 is 1 times 25, you have 25. So you have minus 24 plus 25 as 1 over 4. And you are left with this. Now the next thing is to square root both sides. So you have x minus 5 over 2 all squared. Remember to add plus or minus. Then you have this. Then this square will cancel the square root. You are left with x minus 5 over 2. Remember, I said that when you have the square root of a fraction, the same thing by finding the square root of the numerator over the square root of the denominator. Then the square root of 1 is 1, and the square root of 4 is 2. Then make x the subject of formula, that is 5 over 2 plus or minus 1 over 2. So it means that by SCM, since these are like fractions, you have x equals to 5 plus or minus 1 over 2. So it means x is equals to 5 plus 1 over 2, or x is equals to 5 minus 1 over 2. This will give 6 over 2, or x is equals to 4 over 2. So 4 over 2. 6 divided by 2 will give 3, and 4 divided by 2 will give 2. So the answers are 2, 3. Now, you can check whether these answers are correct by substituting 2 into this quadratic equation. Okay. S is equals to 2. You have s squared minus 5x from the question equals to 0. Substitute 2 there. You have 2 squared. Anywhere you see s, you put 2. So it means this is 2 plus 6 equals to 0. Then that is 4 minus 10 plus 6 equals to 0. So you have 4 minus 10 as minus 6 plus 6 equals to 0. So you have 0 on the left hand side, you have 0 on the right hand side. Since this statement is true, then it means that the answer s equals to 2 is correct. Then you can try for x equals to 3, and you can try that yourself and get back to me whether the answer is right or not. Now, to divide through by the quotient of s, which is 1. Dividing by the quotient of s squared by 1 means that you still get back the same equation. So there is no need for you to divide both sides by 1. You skip step 2 and move to step 3. Step 3 says complete the square on the left hand side by adding that term to both sides. For this particular problem, the expression or the term on the right hand side is already a square. So there is no need for you to add any term to this, because this is a squared. You have s squared here. The term on the left hand side is squared already. And that means that step 4, write the expression on the left hand side is squared. We don't need that 2 as well. Then we'll move straight to evaluate the unknown variable, which is x. Then to evaluate the unknown variable, which is x, we need to square root both sides. That is, you have s squared. When you take the square root, then you take the square root of 9. And remember to write plus or minus. So this squared cancels this. So you have x equals to what? The square root of 9 is 3. So you have plus or minus 3. That means that x is equals to plus 3. Or x is equals to minus 3. And the final answer is x is, you can write it as this, or you write it as x equals to plus 3 minus 3 comma 3 like this. So this is the end of this lesson. But before we go, let's look at what we've discussed today. The method we are considering today is completely square method. And by the name, it means that you are to add a term to the expression on the left-hand side of a given equation. The reason why you add that term is to make that expression on the left-hand side to be written in form of a square. And after you've gotten that in form of a square, then the next is to evaluate the unknown. We've solved some examples and we've gotten our answer, and we've also checked that the answer is correct for x equals to 2 for the second example. The third example here, the b term is not there, the term with x is not in the question, and the coefficient of s squared is 1. So you don't need to divide through by 1, and you don't need to add anything to this equation because the term on the left-hand side is already a square. Now, I have an activity for you. Solve the following quadratic equation by completely square method. You have to use completely square method to solve these questions. The first one, you have 9x squared minus 12x plus 4 equals to 0. The second one, you have x squared plus 4x plus 4 equals to 0. The third one, x squared minus 49 equals to 0. 2x squared minus 6x plus 3 equal to 0. The fifth question, you have 2x squared minus 36 equal to 0. And I'll be expecting your answers. Stay safe. See you next time.